We are doing 4.5b. We are reviewing solving rational equations. To solve a rational equation, I need to find the common denominator so I can cancel out the fraction. Then I, usually make a trinomial, factor that trinomial. So here we go. I've got to find the LCM. I got an x minus 3. I got an x minus 3. And I got a 4. So I'm only going to use the x minus 3. I'm only going to write it one time. But the 4 is also something that is a denominator. So I'm going to say that my common denominator is 4 along with x minus 3. So I can put it like this: 4 along with x minus 3. And I keep them separate. I'm not going to distribute that. I keep it you just keep them in its own separate parentheses. So if that's going to be my common denominator, then I have to multiply every single term by both of those things. Remember, do not distribute. Do not distribute. Okay, ready? So I go through now and I'm going to cross cancel. Like there's an x minus 3 here and there's an x minus 3 up there. So that means that both of those are going to go away. I'm left with 4 times 3. 4 times 3 is 12. Diagonally, what can cancel? X minus 3, x minus 3. I'm left with an x times 4. X times 4, really, it's better to write it as 4x. True? Okay, then. These 4s, they can cancel diagonally. X times x minus 3. I need to be really careful with this subtraction sign. Once you have your fractions canceled, then I'm, trying to get all the terms together so that I can have a trinomial, factor that, right? 12 equals 4x. Now, distribute negative x times x, negative x squared. Negative x times negative 3, positive 3x. Got it? Be careful with the negatives. I hope you guys know that whenever I have a trinomial, I have to have it be a positive x squared to lead off, which means that I want this x squared to go over to the left. 4x plus 3x. I really need everything together. But I'll go slow, like one step at a time, So the negative 7x is going to have to go in the middle of the x's and the 12. It's going to look like that. X squared minus 7x plus 12 equals 0. So what is it? What multiplies to make positive 12 and adds up to negative 7?
Negative 4 and negative 3.
Okay, so x equals positive 4 and x equals positive 3. Thank you. I'm going to check for extraneous solutions. So I need to see, do any of these numbers, when I put it back in my original denominator, does it make 0? I don't want it to make 0. 0 is bad, right? So 4 minus 3, that makes 1. That's fine. 4, okay. So I like this answer. 3 minus 3, 0. I don't want there to be a 0. This is bad. This number is bad, which means this number is the extraneous solution. Okay. I don't want, I need to know what the extraneous solution is, but your only answer now is x minus 4. That's the correct answer. Okay. I'm scrolling down. Please read this question to yourself about Arthur and Cheyenne, please. So the whole thing is that I want to know about how long will it take if they work together versus how long would it take if they worked alone. So what I do is I say the one person plus the other person, Arthur plus Cheyenne equals 1 job. And this is the format for setting up work problems. It's called a work problem. So here's the template. And we use this for every work problem. It's, lost my blue. How many hours it takes them to do the job together divided by how many hours it takes them to do the job alone. So each person, I care the hours together with the other person and then the hours all by themselves.
What does the 1 stand for?
1 job. The whole 1 job that they worked together on. 1 whole job. Okay. Now, they can paint a wall in 6 hours when working together. Oh, Arthur together does it in 6. Cheyenne together does it in 6. So set that up. I got the together. I'm good. Do you like how they're painting in their socks, you guys? No shoes.
I don't like that.
Yeah, I know, it's unsmart. So now, Cheyenne works twice as fast as Arthur. You have to be careful with this. Cheyenne works twice as fast. Arthur's slow, Cheyenne's fast. But then, how do I represent that in alone in my denominator? Because one thing is I don't know how long it takes them alone. So it's an unknown, it's a variable right now. Arthur is slow, Cheyenne is fast. Cheyenne works twice as fast. So since I'm still kind of unclear who's going to be X and who's going to be 2X, because twice as fast means 2X, I have to do a little try it. If Cheyenne does a paint job in 5 hours, let's just say, Cheyenne works twice as fast as Arthur. So Cheyenne does it for 5 hours. Well, what's Arthur going to take? Does he take 2.5 hours or does he take 10? Cheyenne is twice as fast. She finishes the job in 5 hours. How long will Arthur take?
10.
10, because he's slower, twice as slow. She's twice as fast, he's twice as slow. So you have to get those variables in your head. So he's going to take 10. If I were to say, well, now I don't know how long Cheyenne takes. Cheyenne takes like, I don't know. Sorry, it's just, I've been having this on all day. Cheyenne takes like, I don't know, X. I don't know. Arthur takes, didn't we say it was double 5? So it's going to be 2X. So if you're not sure how to set it up, pick a sample number and play with the situation. Because that's what I just did to figure it out. And now I know I'm doing it right. Cheyenne is X. Alone, Cheyenne is X. Put an X in the denominator for alone. However, Arthur is 2X. Okay. I'm now ready to solve. So as I've been doing yesterday and today, I'm going to find a least common multiple between 2X and X. Okay, careful. They both have an X. Great. But then this one has a 2, so I have to include the 2 so that it's represented. So I'm going to say that my LCM is 2X. Because then when I multiply every term by my LCM, you'll see I'm able to cross out this whole thing. So simplify now, 2X and 2X. Those canceled. All I have is a 6. And you know it's like 2X over 1, right? I don't have to say that. Are you clear on that? Now here, this has an X in the denominator. This has a 2X. Well, this X can cancel with just this X. The 2 stays, the 2 remains. 6 times 2. 1 times 2X. 2X. So 6 plus 12 is 18 equals 2X. X equals obviously a 9. Your answers, my friends, need to be in complete sentences. So you need to say Cheyenne. Oh, wait. How long would it take Cheyenne to paint the wall if she were alone? Cheyenne takes 9 hours to paint alone. That was X. How long is Cheyenne? Okay. So the most difficult part is actually putting the word problem together. I'm going to scroll down. Okay. Please read this word problem to yourself. All right, I'm going to set some things up. So X is going to be the speed in still water and Y is going to be the speed of the current. And let me tell you how I knew that in just a second, because I absolutely will. Now, when I'm in a river or when I'm riding my bicycle, or if I'm flying an airplane, the wind affects my trip. Also, in a river, the water speed affects my trip. So I have against the wind or upstream versus And look, it even talks about that in the problem. With the wind or downstream. We're doing a traveling problem. Distance equals rate times time. But as we set it up, I have a chart. It's always backwards. Rate times time equals distance. Okay. Now I'm going to go through the word problem and I'm going to talk to you about what each thing is. Paddling with the current in a river, Jake traveled 16 miles. His distance was 16 miles with the current, with distance 16 with the current. Even though he paddled upstream for an hour longer than he paddled downstream, so I'm gonna have to do an hour longer somewhere, plus 1 hour somewhere, Jake could only travel 6 miles. His distance, 6 miles against the current. Okay, let's talk about this against and with business. Okay. Here we go. So I'm going to be rowing a boat. I'm rowing a boat. Now I have my own strength, my muscles, my arms row. Some people would be stronger than other people, right? So there's that. That's what I call my speed in still water. Like if I were sitting in a lake and there was no movement and I just rowed, that's my speed. I can row this fast, my speed in still water. Now I'm gonna go talk about like being in a river. So I'm gonna row and I'm gonna be in a river with the current. So I row and that's my speed, X, 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 X. But this river, this water is rushing behind me and it's pushing me and I go a little faster, don't I? So if I have this water rushing behind me and I'm rowing, that's gonna be my X plus Y. It's working together and I'm going fast, faster, faster. Look at it, you can't even see me anymore, I'm going so fast. Then I'm gonna write with the current going downstream, X plus Y. They work together. My arms and the water rushing pushes me along faster. And this will be the same. Think of this in the future when you have like an airplane problem or you're riding your bike or whatever it is. Now I'm going to turn around. So now I'm rowing my boat and my speed is still the same. I'm doing my arms what I normally do. However, I now have water rushing against me, and this water that's coming against me is making it harder for me to go, and I can't go as fast, obviously. Two forces are working against each other. Me trying to row and this water rushing against me makes an X minus Y, okay, against each other. So now what I need to do is I need to go through and, well, this is important. So I need you to remember how I got those. Let's see if there's anything I haven't looked at in the word problem. 1 hour longer, I have to keep that in mind. 6 miles against the current, I got that, 6. In still water, X. Jake paddles at a rate of 5 miles per hour. I know his X, it's 5. Jake's speed is 5, which means that I can replace X with 5 because I was just told in my problem, Jake still water speed is 5. So I put a 5 there instead of X. And it's good because I don't want to do X and Y and have a system of equations. It's just too much. This is great. So now I get to kind of work with this. Downstream, so downstream and upstream, right? So it took him an hour longer. When he paddled upstream, it took him an hour longer than the time he paddled downstream. So that means, listen, however long it took him to paddle downstream, I have to add an hour to that because he was slower going upstream. The amount of time it took him to paddle downstream, I have to add an hour to that because when he paddled upstream, he went slower. So it's downstream plus 1 equals upstream. Okay, so now I'm ready to actually like put things together. Well, I can't do rate times time equals distance. I don't have a time. I don't know how long this took him really, except for this hour. I don't know how long. So what I need to do is, since time is the thing that I don't know, that's what I need to solve for. Well, rate times time equals distance. Let's solve for t. Distance divided by rate. So I'm going to do distance divided by rate. And look, I have those filled in. Distance divided by rate. Distance divided by rate. You can't work with time because you don't have any numbers filled in. You knew this plus 1, but there was not x plus 1 or x or any variables there. So distance downstream, 16 divided by rate, 16 on the numerator, 5 plus y on the denominator. Plus I have to add an hour to equal the amount of upstream because upstream took me a long time. So I have to do downstream plus an extra hour to equal my super slow upstream time, right? Then upstream, distance 6 divided by rate. Okay. This part is something that I think some of you might not know to do. And you might not understand why I have to make this fraction in the first place. So real quick, let me say, I was told about the rate, I was told about my distance. Those are 2 pieces of information I have, which means I need to use them. I don't really know anything about the time. It never said 30 minutes total trip, or he was done in 4 hours. Didn't say anything like that. So what I had to do is time is what I needed to then isolate so that I could focus on my distance and my rate. Distance, rate, distance, rate. So I'm going to have you now talk about the LCM. Well, look, 5 minus y, 5 plus y, those are the only denominators. That's it. 5 plus y, 5 minus y. So I'm going to multiply by that. Let's cancel out what we can. We're now going through all this. The 5 plus y is in common. I'm going to cancel that. And I still have a 16 times 5 minus y. This 1, 5 plus y, 5 minus y. Hey, I know that. That's a difference of 2 squares. 25 minus y squared, is it not? Difference of 2 squares? If you see a shortcut, use it. Then 5 minus y cancels, but I have 6 times 5 plus y. 6 times 5 plus y, 30 plus 6y. 16 minus, 16, 5 minus y is 80 minus 16y. 80 minus 16y. Okay. Combine like terms, get everything on one side. I think you should move this y squared over to the right because I want it to be a positive y squared. So I'm going to move everything over to the right. Combine like terms, get a trinomial. So, ready? Here's your answer, people. Y squared, positive, plus 22y minus 75. I'm going to get two answers. Y plus 25, y minus 3. Zero product property, set them equal to 0. I get a negative 25 and a positive 3. What is the speed of the current in the river? You have to know what question you're being asked. Speed of the current, ready? The speed of the current is negative 25 miles an hour. The speed of the current is 3 miles an hour. Have you ever seen a river flow negative 25? Negative speed. And 25 miles an hour. Do you guys know what would happen if there was a river flowing 25 miles an hour? Like,
Someone would die.
yeah, you couldn't, no, you would, yeah. But a positive 3, that's a nice slow. The river speed is 3 miles per hour. Okay? The river speed is 3 miles per hour.
For the time, so for like against the upstream, would it be like 16/5 plus y plus 1?
Yes, 1 plus 1 over 1?
Or plus 1, like adding 1. So that'll be the upstream.
No, you don't add an hour to the upstream. Okay. If I want upstream and downstream to be equal to each other, then I have to remember I go slower upstream. So downstream plus an hour is going to be the time. By the time I finally finish rowing upstream, I'll have gone downstream and then 1 hour has passed. So that's why the plus 1 is next to downstream. It's tricky to think about because it's kind of backwards from what we think, you know? But if I want downstream to equal upstream, I'm going to take a long time upstream, aren't I? So there's this extra hour of time. And that means my quick trip downstream plus an hour, that'll be the time I finally do my whole upstream trip.
And for like the time for the downstream, that would be like without the 1, like on the
No, downstream has the 1 in the equation. I had to put it on this side with the downstream to get the correct answer from what I just explained. Let me end the video just because that I'm still recording.